Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this session we will see how we can troubleshoot a room heater. It is a heater fan, heater blower. How we can test it in detail. I will share all the troubleshooting details for this device. Basically it is a question from my viewer, Mr. Ashraf. Let's start. Electric room heater, it have a fan, then it have a heating body, resistive load. It is 2000 watt JKFTP 230-2000-16-4-4. Then it have a thermal protection PTC switch. Here we have mode selector, from where we can select fan, low heat, high heat, and the leftmost, that is off position. Then we have adjustable thermostat. This is fixed thermostat. It is a PTC switch. At a specific temperature it will turn off the system. That is for protection, and this protection is much higher than this one. In any case, if this thermostat cannot operate or there is any obstruction, the air is not blowing, and this heating body, it is fitted in this plastic here and it is heating up continuously, so it can melt this plastic, it can cause to fire. At that time this protection will enable and it will turn off the system from this contact. It will close automatically at approximately when the temperature, because it is installed very closer to this one, it will increase than 85 degrees centigrade, it will automatically open, and at 43 degree it will close again. Let's see the circuit, and this is just only the fitting. So this is our electrical circuit. We will see the diagram and then we will make troubleshooting. We have line and neutral here input. Line and neutral here. Then we have PTC, the thermal protection. This PTC switch, it is not a PTC thermistor, it is a PTC thermostat. It have no adjustment, it will just only open and close at specific temperature. This thermostat is adjustable, but it will operate at specific temperature and it will close, open and close, so it is a safety. We can say it is a resettable fuse, automatically resettable fuse, but it operates with the temperature. So the neutral line will pass through this resettable fuse and then it will deliver to common of the resistor, the both heating bodies, motor and the neon. This line is coming directly, reaching here, then at this junction the one line, it is going to the heaters. We have 4 sections, 1, 2, 3, 4. So these 2 points are neutral points. Then one line is common for the fan motor, for the neon. This line entering and 3 lines out. One for heater, one for neon, one for motor. This neutral is now finished. Then we have this line. The line voltage will come to the adjustable thermostat, that is here. It is adjustable, so it will maintain the temperature, and when increasing at that time its temperature range will increase. So line will enter in this thermostat, then it will go to the common pin of this selector switch. So this selector switch is a special selector. After this adjustable thermostat, the line will enter in this common wire of this selector switch, that is line. Then we have pin number 1, 2, 3. When it is off, it will give no connection for any terminal. Fan will off, heaters will off. When we will turn to first position, it will give line connection with just only the fan wire. So line will go to the fan. Fan will operate. If we will select to position number 1, at that time it will turn on fan plus the first heater. And if we will select to position number 2, that is full heat, at that time it will operate low line plus high line. At that time our line supply will reach to 1, 2, 3 wires. In first position just only the motor, fan motor. Position number 1, that is to low heat plus motor. At full heat, motor, first heater, second heater. Let's test it. In the first step we will see how we can test power cable. Set it to the continuity. Set this switch to off, selector switch to off, thermostat to full counterclockwise. We connected one line here. Now we will connect the second line at this PTC switch. That means this neutral line is reaching here. Then move to the second terminal, and now we will check here at this thermostat. First we will connect at input terminal at this line, so it is directly on, continuity. Now we will connect to the output terminal the second wire which is going to the selector switch. Connect here. Now slowly adjust the thermostat and you will listen the click sound, and we will see the continuity on this multimeter. Yes. After that it is giving continuity until end. Rotate slowly. It is turned off. That's good. We connected one wire in the terminal and we tested here. The power cable here, good. From this point to thermostat one end, the input side, the cable is good. So we verified the input power cable. We tested the thermostat by adjusting, so it is working. This will connect it at the same point. We will not remove it now. It is now connected here. Now adjust thermostat to full clockwise position, and now take a pin and connect this wire which is going to the motor, that is here. Connect here, so it is giving continuity. At this time we will not find the continuity at this wire, that is for the heater, and we will not find continuity here. Now move to the first position, the first heater, low heat. At low heat we will find continuity at this motor pin, fan motor, so fan motor will work, and we will find the continuity at this blue wire, but we will not find continuity at yellow wire. It is 589 ohms, that is the accumulated resistance, but it is not giving continuity. This is resistance. This is 589, that is parallel resistance of this fan and the heater, but it is not giving continuity. Here we have continuity, it is 0 ohm. So that means this line is connected here. Now move this switch to the full right position, that is full heat. This time we will find continuity at the fan motor. I will set to continuity. Fan motor, the blue wire, that is low speed, and the full speed, that is the yellow wire here. So we are finding continuity here. So at that time it will also apply power to this fan motor. Now when the fan will rotate in this direction, it will repel air to this side, and here in the air side there is this heating element. Air will pass through this heating element and it will cross to the room. Now if you want to test the voltage, set to AC voltage, and I will connect this wire, common wire, to blue wire, common line to blue wire. Turn off the switch, and now we will connect to the first wire here. Now I am applying power. If you don't have a good practical experience in power electronics, never try to repair. Now I will connect the power. You can see this time there are no voltage here. Rotate the thermostat, and this time the switch is at off position. Turn on the switch. The fan started. This time the fan have abnormal sound. Why? Because its one wing is broken and someone applied some epoxy hardener. Now it is unbalanced due to this, the extra amount of epoxy, so it is heavy from this side, so it will not rotate properly. Now just only fan and the neon is working, and we have no voltage at this low terminal. No voltage at low terminal, low heat, and no voltage at high terminal. Just only fan is operated. Fan, it is receiving voltage. But when I will select to the low heat, at that time this one plus this one, these two will operate. So here is the low heat, the blue wire. Now I will I will turn on for a while, because this time this fan is separate, so it will become heat up. So we have 230 volt at this point, and if I will connect to this pin, we don't have any voltage. We have just only at low terminal, that is here. At fan, just only fan will operate. The red wire, that is common wire, so I will connect at red wire, and we will connect to this low heat. Here is low heat. Now this multimeter will show the low heat, and this multimeter will show the full heat. Set to low heat, it is giving 226 volt. This is just only in millivolt. When I will turn on at both, the both multimeters are now showing the voltage. So our both heaters are receiving voltage here now. So in this way we can verify that there is heat, there is mod selected. Now we will check the input resistance. How we can verify? Using the ohm meter. Now if you want to test the heating fan as a complete unit, connect ohm meter to the input line terminals. To the line terminal here. Rotate thermostat knob to fully clockwise at full temperature. Now select mod selector to the fan. This time 770 ohm resistance for the fan motor. So fan motor is now in the circuit. This is a connection for the fan motor. If I will remove, the resistance is open, no resistance. When I will connect it, so the fan is in circuit. Now move mode selector switch to number 1 position. It is 170 ohms. This time fan plus the low heat, these two are in circuit. If we cannot find this resistance at that time, this circuit and this circuit, it have problem. If we cannot find the resistance at low heat mode, that means our fan is bad. When fan is connected, it will give 769 ohms. When we have parallel resistance of the first heater, at that time it will give 170 ohms. Now move the selector to the last position, the full heat. At that time fan, low heat, full heat, these all sections will connected to this line voltage. If we cannot find the dropping resistance, that is 100 ohm resistor, maybe our this line is open, or maybe the heater is open. If we cannot find the resistance at these heaters, that means we have problem here. Maybe these lines are disconnected, maybe the heater is open. Now we can check the heating element. How we can test? This is low heat, this is full heat, and this is our common terminal. So common terminal is common for the both. So we can connect one test lead here, the second test lead to this input terminal. It is 218 ohms, and this terminal, it is 340 ohms. When these resistors will become in parallel, at that time the RT will decrease. So that is the reason when this 340 ohms and 100 something are coming in parallel, total resistance is reaching to around 100 ohms, 120 ohms. In full heat at 2000 watt, it will give the resistance around 113 ohms. Here 169, 180 ohms, like that. And here 700 ohms at the fan. So in this way we can test this circuit. The configuration of this heating element, it have 4 sections, 4 resistors, 1, 2, 3 and 4. These 2 points are common points, the red one. When we will use low heat, at that time this outer resistor and this outer resistor, these 2 sections will work, because common terminal is this and low heat terminal, this one and this one. These 2 will come in the circuit, and it have high resistance, around 300 ohms. And when we will connect this one, at that time this section and this section will become in the circuit, and it is already in the circuit. So 4 resistors will become heat up. If we cannot find the resistance, maybe this heating element is damaged. In some cases this PTC resettable fuse, it also damages. We can check continuity if it is working or no. It is giving continuity. If it is open, totally open, at that time we need to replace it, because it is safety and it must be installed. I hope so this video is informative. If it is informative, hit the like button. If you have any question, let me know in the comment box. In the next session, we will see how we can troubleshoot using series test lamp. If we don't have multimeter, how we can test using series lamp. In next session, we will see it. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.